In this course, we're going to be developing control systems. And so let's look at the phases of the design process for a control system design. So, not surprisingly, we begin first with studying. We're interested in knowing something about this system, and we need to control the system to behave in a certain way. So we need to know, for example, what are the sensors that we have on board? That's going to tell us the kinds of things that we can measure. And we also want to know about the actuators, because that tells us the kinds of things that we'll be able to control. And finally, we'll also need to know about the physics of the system. How is it going to behave when we're not controlling it? That's what physics tells us. Physics tells us what happens when time is in control and we aren't. So after we've studied this system, we need to model the system. So we create some kind of an abstraction for the physical system, its sensors and actuators. And if necessary, we simplify that model. So this might be through linearization, leaving out variables, making assumptions about where the system is going to be in the state space when we begin and when we end. Those kinds of simplifications can make our design easier. And once we've done the model, now we need to analyze the model. Is it stable? Is it robust? And by robustness we mean if we made a mistake in our simplification or an improper assumption in our abstraction, will the system still behave like we want it to? How sensitive is it to changes in the design parameters? And how will it perform? We may need it to act very quickly, or because of the physics of the system, if it acts too fast, that might cause us to go unstable. So after we've done a little bit of analysis, we can put forward our design. So what are the requirements that we'd like to fulfill? What's the controller type that we'd like to use? What kind of parameters do we need to have? And once we've specified those parameters in the analysis section, how do we select those parameters for our design to achieve the requirements? So now, once we've selected those parameters, determined our controller type, it's time to verify the system and validate that our approach is correct. So this is very frequently called V&V. So when you do V&V, you're sometimes simulating the system to make sure that your assumptions were correct and that the physics seem to match your model. You'll do some more analysis to make sure that, again, your implementation seems to match. You might also do hardware in the loop testing, HWIL, sometimes it's abbreviated, where you take some physical portions of your system and see how they behave when you use your controller. And you might end up having to tune your system online. So this goes back to the robustness and sensitivity of your system. If you made simplification assumptions that turns out to not match your hardware, you may need to change some of your gains and parameters in the design. So, where do we go next? Well, once we've got all of these pieces and they're laid out ready to go, we can actually think of the control design process as a series of steps with arrows in between. And the arrows in between tell us the order in which we do this, and the verification and validation loop is basically a feedback loop. If our verification and validation parameters aren't met, we go back to the beginning. Study, model, analyze, and design.